direct method of proof. So we are going to perform the direct method of proof of statements of the form P implies Q. So here symbolically we can write it as we can mention the P implies Q as, so this is the notation of the P implies Q. Then now under the of part 1 in an advanced level. So now we are going to perform the proof by means of one illustration or an example. So here, in order to prove the direct method of proof of the statements of the form that is P implies Q, so here is one illustration or an example. So in our example, we have to prove that if x is an even, that is an even number, then we have to prove x square is also an even number. So here the if condition, that is the given condition, is of x is an even, then to be proved condition is of x square is also an even. Then proof starts now. So in our proof, so here as per problem or as per the condition which is given, so here x is an even number, so here x is an even, that is even number which is already given as per the condition. Then now here symbolically I am going to write it as symbolically we can mention it as x is, so that is x equals to even number, so here we can write it as even, or in other words, so here even number. But even number, so according to the definition of an even number, so here as per the definition of an even, so here even number is given by means of two multiplied with any integer. So 2 multiplied with any integer will give us an even number. But here let us assume, so any integer k, so here let any integer be k. If I have assumed it as k, then the next logical step will be off. So what implies that is even number. So here even is 2 into, that is any. So in this manner we got, so here therefore an even number is given by means of 2k. But as per the condition which we have written, so here in the previous logical step, that is x is equals to even number which is already given. So then now, but x is equals to even number, which is already given in the condition, then the next logical step will be off. So that implies x equals to number can be replaced by means of 2k. But as per the condition which we have to prove, so we have to show x square as also an even number. But here the logical step is off. So x is, but here we need x square. We have to prove x square as also an even number, but here we have to get the exponent as 2. So here I have to square on either side. So here by squaring on both the sides, so when we square on either side of the equation x equals to 2k, then the next logical step will be off. So that implies left hand side x must be squared and right hand side, that is 2k, also must be squared. Then the next logical step will be off. That implies x whole square, that can be written as x square, is equals to, so here square is applicable for both 2 and as well as k. It is in the form of, so here ab whole power m, so it can be written as into the identity, that is ab whole power m. So m, that is a power m into b power m. So in this condition or this identity, so based upon this identity I can write the logical step as, so this exponent 2 is also applicable for both, that is 2 and as well as k, 2 square into, that is square square. Then the next logical step will be, so that implies x square is equals to 2 repeatedly multiplied twice, so 2 2 is of 4 and here it is of k square, so we can get it as x square equals to 4k square. Whereas in the next logical step we can split this 4 as 2 2's. So here in the next logical step I am going to split this 4 as 2 into 2. Then now the next logical step will be off. So x square is equals to, so therefore in the previous logical step is split as 2 into 2, then k square is written as it is. Then in the next logical step we can write it as, that implies x square is equals to, I am going to group, so 2k square, so here as one term. Then now in the next logical step, that implies, so x square is equals to 2 into, so I am going to consider, in case if I assume k as 1, then I will be getting k square, that is 1 square as 1 into 2 as 2. In case if I assume k as 2, that is 2 squared, 4, 4 into 2 as 8. Then in case if I assume k as 3, 3 square 9, 9 into 2 is of 18. So those are all of integers. So here that is of, so here instead of 2k square I am going to write it as L. So here since 2k square is equals to L, L is another integer. Then now, but the next logical step will be of, that implies x square is equals to 2 into, but here we got L as an integer, so here we can write it as L as the integer, but here as per the definition of the even number, so 2 into integer is nothing but an even number. So here the next logical step will be off, so that implies x square is equals to 2 into integer is nothing but an even number. So here we got this logical step by means of the definition of is equals to 2 into integer. Then now, so therefore we can write the statement as, hence equals to can be written as an even number. So here we have started, in case of a direct method of proof, so we have started the condition with the an even number when we assume x is an even number statement P, and when we assume the x square is also an even number as the statement Q, then we have started the proof from the statement that is P, and we have ended up with the statement that is Q. So here, hence it is proved. Here we can write a note under this direct method of proof. In order to prove in direct method of proof, of statements Q with and we end up